My dear students, very good morning. Today topic is pseudo force. This pseudo force create some tsunami in Newton laws. Okay, welcome to LARA physics. You will learn some knowledge from the LARA physics. Okay, before I start pseudo force, we will discuss about the frame of reference and inertial frame and non-inertial frames. So what is the frame of reference? First you see here, for example, this is the earth surface. This is the earth surface and I will draw the one fixed object like a tree. One person stand here, one person stand here. So with respect to this person, the tree is fixed object. So that means I will draw the coordinate system along y-axis and along x-axis. So here this is the x-axis, this is the y-axis. So about this fixed point, so here this system we called frame of reference. Okay, if this frame of reference is rest position or constant speed, rest position or constant speed without acceleration, then that frame of reference we called inertial frame of reference. Inertial frame of reference. Inertial frame of reference. Okay, now this system is accelerated. This system is accelerated with respect to this person. With respect to this person, then the system is called non-inertial frame of reference. Non-inertial frame. Non-inertial frame of reference. Non-inertial frame of reference. Generally, frame of reference are divided into two types. First one is the inertial frame, second one is the non-inertial frame. Here in inertial frame, so a coordinate system or frame of reference is rest position or constant speed without any acceleration, then that frame of reference we called inertial frame of reference. Inertial frame of reference. Here all Newton laws are valid. You can use any first law, second law, third law in inertial frame. But in non-inertial frame, don't use. Here, Newton laws are not applicable in non-inertial frames. Newton laws are not applicable in non-inertial frames. Okay, we will discuss how to solve that problem. For example, I sit in bus. When bus suddenly started, what happened? I simply move backward side like that only. So who pushed backward? I don't know. Next, so bus is moving 70 km speed. Suddenly the driver applied the brakes. What happened? Simply I tilt forward direction like this only. Who pushed back from the backward? I don't know. So that means that bus we called non-inertial frame. So what is the forces acting on non-inertial frame? That is always opposite to the motion of the body or motion of the system. Once again see here, when body is moving forward direction, simply pseudo force is acting backward direction like this only. Is it right? Next, car is moving fastly forward direction, the driver is applied the brakes. I simply felt forward direction like this only. Why? Because of that car wants to rest position, it moving backward direction, I tilt forward direction. That means a force which is acting opposite to the system. A force which is acting opposite system, that force we called pseudo force or imaginary force. Pseudo force or imaginary force. That pseudo force create some tsunami in Newton laws. Okay, so why? Because of all Newtons are failed in non-inertial frames. Now, how to overcome that non-inertial frame problems? Okay, see here. For example, I will tell you one small example based on the inertial frame and non-inertial frame. See here, already you know apparent weights in lift. So for example, this is the lift. This is the lift. I take one weighing machine, I stand on the weighing machine like that only. When lift is moving upward direction with acceleration A, what happened? The weight of this person acting downward direction mg. At the same time, the normal reaction acting upward direction. This is the action reaction pairs. Okay. So now they are asking question, what is the normal reaction? Is it right? So simply how to calculate according to Newton's second law. Why? Because of if I stand here and observe this entire system. Why? Because of I am standing on the inertial frame, that means earth. Okay, now I stand on the earth. What happened? So here this body is moving upward direction. According to Newton's second law, the resultant force F is equal to N. Why? Because of this resultant force is acting upward direction. You take first normal reaction. So N minus weight is acting downward direction. So F is equal to MA, that equal to N minus mg. So normal reaction N is equal to, how to write here, N equal to mg plus ma. Okay, this is okay. Next, this is the inertial frame. Inertial frame. Next, second situation. So what happened? Simply I take same lift. The lift is moving upward direction and one person standing. So here I also stand here. Okay. Now see here. Now I observe the what is the normal reaction, everything like that only. So in this situation, what happened? If I stand here, so this person is always appears rest position. So that means weight of the body is acting downward direction mg and the normal reaction is acting upward direction. With respect to this lift, so myself rest position, I am rest position. This person also rest position. So that means N is equal to mg. Earlier what you got here, N is equal to mg plus ma. If I measured, I stand inside the lift and measured, I got reading N is equal to mg. Finally what happened? Here Newton laws is not applicable. Here Newton laws is valid, but here Newton laws is not applicable. Why? Because of here this term is missing. The term is missing. So that's why. So finally our all scientists are meet together. They discuss fighting together. They too much fighting. Finally they got one conclusion. What conclusion? After that big war, they got conclusion. One additional force is required. That force, when lift is moving upward direction, this is the one lift is moving upward direction with acceleration A. With acceleration A. At that time, so simply one pseudo force is acting downward direction. Pseudo force is acting downward direction. That pseudo force F is equal to the acceleration of the system and mass of this object. So that force is added here. So simply N is equal to mg plus a. Now it is accepted. Earlier, so what happened? So we got wrong answer. Now when you added additional one imaginary value, that imaginary value if you added, so finally you got true value or right value. Now our Newton says, now it is good, I got answer. Is it right? So based on this concept, we discuss some JEE and NEET numerical problems. See here. Next, see here, this is the trolley. This is the one trolley. I take one pendulum suspended inside the trolley. Now what happened? The trolley is moving with acceleration, so 10 meter per second square. 10 meter per second square. They are asking question, what is the angle made by the pendulum with y-axis? With vertical. See here, with the vertical. Now this see here, when this is the non-inertial frame, I sit inside the trolley and observe. When I sit inside the trolley and observe, this trolley, this is the pendulum comes like this. That pendulum comes like this only. That pendulum, initially when trolley is rest position, that pendulum like this only. When that trolley is start to move, that pendulum is comes like this. At equilibrium state, so when object is that the system is moving forward direction, pseudo force is acting backward direction F. The weight of the body is acting downward direction mg. The tension in the string acting T along the string. Now it is in equilibrium state. At equilibrium state. So if you see here at equilibrium state, so what happened? I resolve two components. Here tension I resolve into two components. Along x-axis, another is the y-axis. Now this pendulum makes an angle theta. This is also makes angle theta. Next, this is the T. So angle, this is the angle theta. Say component always, this component came cos theta. Next, remaining T sin theta. Just you remember, a component which is makes angle theta, that component is always cos theta. Just I will tell you one shortcut trick. Okay, see here. Now it is in equilibrium position. Upward forces is equal to downward forces. LHS is equal to RHS. So here along x-axis, T sin theta is equal to pseudo force. Next, here T cos theta is equal to mg. I consider this is the first equation, this is the second equation. If you divide these two equations, so here this one, so T sin theta by T cos theta equal to, so F by mg. So here this T kills this T. So sin by cos can be written as tan theta equal to F is equal to ma. So it is accelerated backward with acceleration a. Why? Because of the trolley is moving forward direction with acceleration a. This bob also moving same acceleration but opposite direction because of pseudo force. So acceleration of the trolley and mass of the bob. So simply mass of the bob, acceleration of the trolley by mg. This one cancel. Finally you will get here simply acceleration of the, so simple see here, a value, how much value is given? 10. G value approximately I take 10 value. So tan theta is equal to 10 by 10. So you will get tan theta is equal to 1. Theta is equal to 45 degrees with the vertical. Okay. Just you copy this problem. I will tell you one more problem. See here. Next, this is the one wedge. That means wooden block I made with incline, that is called wedge. This is like a one wooden piece. I cut like a inclined plane, smooth inclined plane. So we called wedge. So here the mass of the wedge is capital M. I arranged one block here. I arranged one block here. Like this. And if I apply the force like this with force F and acceleration A. Okay. Now what they told here, what is the minimum force is required to keep this small block in equilibrium position or without sliding down. So before I calculate force, I calculated acceleration. So if I know acceleration, so here total mass of the system into acceleration we call force. Easy method. Any problem in mechanics, first you calculate acceleration and multiply with the total mass of the system, you will get force. Okay. See here, when I pushed in this direction with force F, at the same time pseudo force is acting backward direction. Force is applied in this direction, pseudo force is acting in this direction. This is the pseudo force. Now our earth says, I also acting on this body, I want to pull downward direction. Earth says, I want to pull downward direction. Okay, no problem. Carry on your work. mg. Okay. When I pulled like this, in the situation what happened, when I push it like this, at the same time that small block also, they simply create some action reaction pairs like this only. So when I push like this, that block also pushes like this. Is it right? On the time what happened? So some normal reaction is acting. That normal reaction I will take in this direction. That is normal reaction. Okay. Now if it is in equilibrium position, so what I will explain here, if it is rest position. So what I will explain here, this normal reaction resolve into two components. One is the here along the force and another is along the weight mg. So if you see here, it makes an angle theta. Why? Because of the inclined plane makes an angle theta. This is also makes an angle theta. So earlier I told you, see here, a component which is makes an angle theta, that component simply I represented by the cos theta. So remaining component, so n sin theta. Okay. So at equilibrium position, what happened? Upward force is equal to downward forces. LHS is equal to RHS. So that means here n sin theta is equal to F. Upward forces. N cos theta is equal to mg. Next. So if you divide these two equations, what happened here? This is the first equation. This is the second equation. Okay. So dividing these two equations, n sin theta by n cos theta is equal to F by mg. So this one cancel. This is the tan theta is equal to, so here force. So force F is equal to ma. So how much force acting here? F is equal to ma by mg. So cancel. So here acceleration of the system, entire system A is equal to, so g tan theta. Now they asking question, how much force is required to pull the entire system to keep this small block in equilibrium position. So that means I will write here that force F is equal to entire mass of the system, capital M, mass of the wedge and mass of the block, into what the acceleration here? A. Now this value substitute here, F is equal to capital M plus small m into G tan theta. So this is the minimum force required to keep the small block on wedge in equilibrium position. Thank you, my dear students. Remaining questions, number of questions is in textbooks and materials is available. So, but you should be remember. So, way of approach, how to solve that problem. You should be learn techniques. Those students are learn techniques. They can solve any type of problems in physics. Don't by heart. Just think, apply the logic and solve the problem. Okay, thank you, my dear students. Have a nice day.